Hi, today we're going to talk about the physical attributes of the Colorado River, its streamflow, its sediment transport characteristics, and the shape and characteristics of the channel itself. The river of the late 1800s and the early 1900s was a large river all the way to the sea. This is a photograph of the inland port of Yuma, Arizona, just at the US-Mexico border. This is a photograph, old photograph in the Delta in Mexico, a river with abundant water large enough for boats to carry supplies from the ocean in and supply the mining camps on the California-Arizona border. This is a photograph of John Wesley Powell's boat on the second Powell expedition through Grand Canyon. A harsh landscape in Grand Canyon, bare sandbars, the world of the late 1800s. The attributes of streamflow, sediment transport, a river that was very warm in summer, cold in winter, was a harsh environment in which the species of fish developed unique attributes to live in that environment. In fact, the environment of the Colorado River was so unusual that with evolution, 75% of the species native to the Colorado River live nowhere else on the planet. Most of the fish of the Colorado River are unique to the Colorado River system and adapted to that harsh environment. The river of today is a very different place, transformed by dams and diversions. And I divide the river into three unequal parts. The Delta, just down in Mexico, an area where the river is confined in levees with almost no flow. The transformed section of the river between Hoover Dam and Yuma, in which approximately half of the total length of the river is now reservoirs, and much of the rest has been channelized or confined by levees. And then upstream from Lake Mead, we have a relatively wild section of the continent. Grand Canyon, Canyonlands, the Uinta Mountains and Dinosaur National Monument, Black Canyon of the Gunnison National Park, some large reservoirs, Lake Powell, Flaming Gorge, the Aspinall Unit, Navajo Dam, but still long sections of free-flowing rivers between those reservoirs. And the restoration challenges are very different in this relatively wild part of the river, this transformed section of the river, and the Delta. This is a hydrograph in which time is on the horizontal axis and the amount of water flowing in the river at any time is shown on the vertical axis. So when the peaks are high, that's a big flood. And this is the period of time measuring the Colorado River at Lee's Ferry, just downstream from modern-day Glen Canyon Dam. The floods reached as much as 100 to 120,000 cubic feet per second, but the lows were as low as 3,000 or 5,000 cubic feet per second. The fundamental attributes of how dams affect the river flow in this section at Glen Canyon and elsewhere is that we don't change the total amount of water that's flowing in the system, but the floods are reduced, the base flows are increased, the river flow is more even throughout the year, but every day the flow goes up and down and up and down and up and down to produce hydroelectricity during the day when we use it. So this is a blow up of the flow regime of the post-Glen Canyon Dam Colorado River. Reduced magnitude of floods, increased base flows, tides associated with hydropower production, no change in annual volume. Downstream from the Grand Canyon, we move a lot of water to the upper half of the transformed section, but then big diversions begin to take water out of the system and almost no water makes it to the sea. This is the land of long big reservoirs and successive depletions of water. Other parts of that section have been completely channelized. This is a photo match, and this is the average hydrograph of the river before Hoover Dam. Yellow after Hoover Dam, you can see a great reduction in the flood regime. And in the delta, this is the hydrograph of the river before the big dams and diversions, and this is the amount of water today that we release into Mexico, and all of that water is then diverted to irrigate farm fields in the Mexicali Valley, and essentially no water makes it to the sea. So the issues are very different from place to place. The other fundamental attribute of the Colorado River is that the Colorado, meaning red, had a very high sediment load. And that sediment comes from the eroding desert arroyos and rivers of the Colorado Plateau and the Basin and Range. So the water comes from the margin in the Rocky Mountains. The river is a clear, cold gravel stream, and then as the river crosses the desert, more and more sand and mud enters the river, and the river transforms its attributes. So it becomes a high suspended sediment load river going downstream. The width of these bars is proportional to the annual sediment yield before humans significantly changed land use patterns in North America, and the Colorado River had the highest amount of sediment transported to sea except for the Missouri-Mississippi system. This is a photograph of Lake Powell at a time of high stand in 2003, and this is Lake Powell, a photo match during the low stand. This is all the accumulated fine sediment that is now trapped in Lake Powell. So now we have dams throughout the watershed that control the water. The floods are less, but we're still sending water out of the upper basin down to the big users downstream, but we're trapping sediment throughout the reach, and so some sections of the river have too little sediment for the amount of energy that the flows have to transport sediment, and they erode and evacuate sediment, and the problems are erosion. In other places, far downstream where sediment pours in, the problems are sort of too much sediment. And so we have areas where we confront issues of too little sediment and areas where we confront issues of too much sediment. There are many recovery programs aimed at recovering the species, these endangered endemic native fish. And I'm going to now talk for a few minutes about how we deal with sediment deficit issues in the Grand Canyon and the Glen Canyon Dam Adaptive Management Program. Eddy sandbars in the Grand Canyon are a distinctive relic of the pre-dam landscape. They have a number of important resource values to river users, ecosystem attributes, and purposes of national park management. Eddies in the lee of rapids collect some of the transported sediment and build these eddy sandbars. Big eddy sandbars are sources of sand to be blown by wind high up. In some cases, these high dunes protect archaeological sites. If we wanted to really solve a problem of too little sediment, We could add sediment by dredging sediment out of Lake Powell, passing that sediment downstream into the Grand Canyon. But the costs are very high, $200 to $500 million. We do not have political consensus in this country to actually rectify the problem in that way. But the Paria River, located 25 kilometers, 15 miles downstream from the dam, delivers a significant amount of sediment, 1 to 3 million tons of sand a year, depending on the year. And the present paradigm is that whenever sediment comes out of the Paria River and dumps into the bed of the river, high releases from Glen Canyon Dam are staged to stir that sediment up, get the river royally, and then rebuild eddy sandbars. These flood releases, called controlled floods or high flow experiments, are short in duration, 7 to 3 days in length. They can only be that long in duration and that high in magnitude because we're mobilizing a much smaller amount of sediment than the wild river. In the background here in brown are the natural floods that would have occurred in the Grand Canyon were Glen Canyon Dam not in place. You can see these floods of today are nothing like the floods that would have occurred naturally, but these floods can't be any bigger than that because they would cause erosion rather than beneficial effects. When these floods stir sediment off the bed, they build eddy sandbars. So these are the beneficial effects of these floods. And when we look on average at the response of the system, we see these last two data points are the average size of eddy sandbars after the latest floods that have occurred in 2012 and 2013. This data point here is just before the 2014 flood. And it looks like we're building sandbars in Grand Canyon. In Marble Canyon, a little closer to the dam, we're also building them, although we still have a challenge. We're building sandbars where we don't have much sand to work with, but it all looks good and we have a monitoring effort to work on that. It's a difficult and challenging task. And so I've tried to explain to you that the Colorado River has three parts: the upper river, the transformed river, and the delta. The challenges are much more difficult and more piecemeal the closer you get to the sea. You have fewer short river segments to work with and not much water. Further upstream, the river is perturbed into deficit or surplus. In Grand Canyon, the problem is we don't have very much sediment to work with, and so we have short duration floods to stir up the small amounts of sediment that we have, build eddy bars temporarily, wait for the next flood. Thank you.